Hi everyone, here is the next in the podcast talking about section 2.5, which is graphing quadratics in vertex form. If you remember back from Algebra 1, we learned about graphing quadratics and graphing parabolas in what we call standard form. And we will come back to standard form later on when we talk about quadratics when we get to the quadratic chapter. However, it should be, because we're talking about parent functions, we're going to talk about transformations, it's important to talk about different formats that we can sometimes have an equation or a different kind of function in. And so here we have a quadratic function, but it's going to be in a little different form, which is called vertex form. Now, when we graph parabolas, here is the new formula that we're looking at. So we're going to be looking at this formula, y equals a, and then the parentheses, x minus h quantity squared, and then plus k. Now, if you remember back from either geometry or back from chapter P in trig, you will realize you've seen the h's and k's before, and that's from the equation of a circle. Now, parabolas and circles have things in common. They are both considered what we call a conic. And so that's one distinguishing factor. But notice that the parabola looks a little bit different than what the circle looked like. So for the parabola, we have y, again, equals a, parentheses, x minus h quantity squared plus k. The vertex will be hk, just like the circle. And if you don't remember the equation of the circle, here's just a quick remember. So again, this is a circle, a little bit different from a parabola. So a little bit different. And then the axis of symmetry is just going to be h. So what we're going to do is we're going to look at through these four equations and figure out the vertex and the axis of symmetry. So for the vertex, we're going to start out. So my h is here, my k is here. By the way, my k value can always be trusted. You're going to take the sign with that. So if it's a plus, it's a plus. If it's a minus, it's a minus. However, inside the x minus h, this one is tricky because it's the opposite. So you'd have to think about there's a minus in the formula, so necessarily you won't necessarily have to take the negative with it because it's supposed to be in the formula. So in our first example of y equals, and then x minus 2 quantity squared plus 3, my vertex is actually going to be 2, because again, there's the minus, don't take it, and then 3. And again, my axis of symmetry would be just my h value of 2. This again is where it folds in half. The next equation, notice it does not have a k value, so therefore we would consider that 0. And so we would have 4, again it's a negative, so don't take it with it in that one. So 4, 0 would be the vertex, axis of symmetry would be 4. Then for number 3. So for number 3, notice it changed to a plus. So therefore, there must have been a negative in here at some point. So therefore, my h value will be negative 3, which is also my axis of symmetry. And then this value can be trusted, so negative 1 for the vertex. And finally, this one's actually just a regular quadratic, and later on we'll use the term parent function for him. And so because he's missing his h and k, they're both going to be 0, 0. And the axis of symmetry is just going to be where x equals 0, or better known as the y-axis. So what we're going to do now is we're going to be graphing a quadratic in vertex form. And again, this whole chapter, a lot of it is graphing, 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 graphing. So very important stuff. So we have 2 examples to do. So for number 5, we're always going to identify the vertex just like what we practiced. We're going to make a table with 5 points, make sure that the vertex is there, and then we're going to plot those points, and you should see some symmetry there, and then draw our parabola. So first of all, let's identify the vertex. So my vertex is going to be 4, 3. So I'm just going to put that here. 4, 3, that's the vertex. And so with that, I know that 1, 2, 3, 4, my axis of symmetry, where it folds in half, is going to be at 4. And at 4, 3, 1, 2, 3, this is going to be where the vertex of my parabola is. Now, notice there is no negative numbers in front of the parentheses, so that basically tells me that my parabola is going to open up. And then from here, now that I have the vertex, then let's get a good old table of values. And so let's go around that vertex. So when we go around that vertex, let's see, I always like to go like 1 to the left and then 1 to the right, and then 2 to the left and then 2 to the right. So if I have 4, 3, which is my vertex, I'm probably going to want to do 3, because that's 1 to the left, and 5, because that's 1 to the right of 4. And then I'm going to go 2 to the left of 4, so that'd be 2. And then I need to go 2 to the right of 4, which is 6. And then we're going to plug these lovely values in. Remember, f of x is equal to y, so that's really what you're finding. So therefore, when we plug that in, again, these are my x values, so I'm going to have 3 minus 4 squared plus 3. Well, let's see. 3 minus 4 is negative 1. Negative 1 squared is 1, and 1 plus 3 is 4. So now I've got my ordered pair, and I should probably write that a little bit better, and so it's going to be 3, 4. So 1, 2, 3, 1, 2, 3, 4. Next, put in 5. Now, technically, I don't have to put in 5 if you remember your symmetry, because if you go 1 to the right and 1 to the left, if you remember by using symmetry, we're going to get the same y coordinate as the one before. And you can double check your math. 5 minus 4 would be 1. 1 squared is 1. 1 plus 3 is 4. So again, a parabola is symmetric, so you can get values on either side. And then next, let's try 2. So 2 minus 4, quantity squared, plus 3. So 2 minus 4 is negative 2. Negative 2 squared is 4. 4 plus 3 is 7. So I'm going to get 2, 7. So I don't even know if that'll fit. 1, 2, 3, 4, 5, 6, 7. Ooh, barely. And then again, I don't necessarily need to do the other one because of symmetry. I know what it's going to be. It's just going to turn out to be 6, 7. That's the thing about going one way, go 1 to the left, 1 to the right, and then 2 to the left and 2 to the right, because you can use symmetry and you won't have to plug it in all these times. And there's my parabola. There's my, again, my 5 points. So it looks pretty nice. Okay, last one. Same idea. Again, find, this one's got a really cool axis of symmetry at -2. So we have some negatives here. Again, so this is where it folds in half. My vertex is going to be at -2, and I can trust that k value, so that's -2, -1. And there's no negative in front of my x squared, so I know this is going to make a U shape. It's not going to go backwards. And so then I want to again go 1 to the left of -2, which would be -3, and 1 to the right of -2, which is -1. Pick one of these to plug in. Let's do the -1, because remember, we can get 2 for 1. So I'm going to have, let's see, let's do -1. So -1 plus 2 squared minus 1. So this would give me 1. 1 squared is 1. 1 minus 1 is 0. Cool. So now I know I've got these values here and here. And then I should probably go 1 more to the left. So 1 more to the left would be -4. 1 more to the right would be 0. And let's see, which one should we plug in? Let's plug in 0, because 0 is nicer. So 0 plus 2 squared minus 1, so that'd be 0 plus 2 is 2. 2 squared is 4. 4 minus 1 is 3. So I'm going to have 0, 3. So this is -4, 3. And again, I've got my 5 points. You make your parabola. So then if you just follow those steps, you can always be able to graph a parabola in Vertex format. And as always, have a great day.